Morning. In this presentation, we're going to talk about why these engines are described as the four-stroke, five-event cycle engine. So once again, they are described as a four-stroke, five-event cycle engine. And so to get us started, we're first going to talk about what's a stroke. Okay, so when we talk about the scripture of this thing, so if we take a look at this guy here, see if I might want to focus that just a little bit for us first. There we go, clean that up a little bit. So a stroke, in our presentation here, you've got your crankshaft. When this crankshaft is up here, that's what's described as top center, or sometimes referred to as top dead center. Really no difference. It's just that there's two different terms that you'll hear it is either top center, bottom center, or bottom dead center, trying to infer a little more exactness. You'll hear the term TDC or bottom center, whatever, or bottom dead center when we're in reference to doing some timing of the engine and some things like that. Okay, so a stroke, we start up here at top center. When that crankshaft rotates down here to the bottom center, 180 degrees, and if we're looking at the first one, we will have completed the intake stroke. So that 180 degrees of crankshaft travel. So I might just take a second and focus in on the actual crankshaft here, where you've got, this is out of a four-cylinder engine, and you can see how the crankshaft journals are directly opposite of one another on this guy. But, so, when this number one rod journal here, because it's on a Lycoming engine, it's always the right front cylinder, which is number one. If it was a Continental, the right rear would be your number one cylinder. But since it's a Lycoming crankshaft, and it's your number one rod journal, when it rotates from top center, then down to what would be bottom center, the cylinder being over here, that would have been your first intake stroke. 180 degrees of crankshaft travel. Now, it gets confusing sometimes when people are talking about that, how many degrees of stroke. It sometimes gets confused with the event. And the event is longer than the stroke. So we'll be talking about the event here in just a bit. But, so talking about that stroke. 180 degrees of crankshaft travel. Okay, so taking a look at the four strokes, we said the engine is described as a four-stroke, five-event cycle engine. So we start off with, over here, as we mentioned, we're at top center. Crankshaft does that first 180 degrees. I have completed my intake stroke. That's, of course, where the intake valve would be in, bringing those intake gases and trying to fill the cylinder as best possible with that fuel-air mixture. Then once we hit bottom center and we are heading back up, then we're going to be on the compression stroke. So that's and they do have test questions that want you to have those memorized. You know, what are the four strokes in the order that they occur? So we got our intake, then we compress that fuel-air mixture where both our valves will be closed there. Then when we go around the second time to get our other two strokes in, as ignition is going to occur up here, driving this into its power stroke. So that second circle we're starting on here down, driving down, that's the power stroke. And then, of course, once we hit bottom center and we're heading back up, then, of course, our final stroke is our exhaust stroke, where the exhaust valve would be open and we are pushing out those gases out the exhaust system. So intake, compression, power, and exhaust. The event is a little bit different. So, in fact, let's have you can take some notes on this or refer to your notes that you might have from this. So our strokes, of course, were intake, compression, power, and exhaust. The events, I'll list those out to you. Just like we have an intake stroke, we're going to have an intake event. And then followed by a compression event. And then there's going to be ignition, And then the fourth event can be called either the compression or power. It's usually best to kind of keep it the same as the strokes. So you could call it the power event. And then, of course, just like you have the exhaust stroke, you're going to have an exhaust event occurring. So once again, in the order that those occur, you're going to have your intake event, compression, ignition, power, and exhaust. Now, the why the stroke and the event are different is where we started with the crankshaft up here at top center and was beginning that intake stroke. The intake event actually already began before we got up to this point. So if I actually go back over here to the exhaust, where I was on that last stroke, where I'm pushing the exhaust gases out here, as this piston, the crankshaft would get up here about probably 10 degrees before top center, my intake valve would open, and while the exhaust valve is already open, it actually closes a little bit later. So, in fact, let's go ahead and describe that point right there when both those valves are open at the same time. So at the end of the exhaust stroke and the beginning of the intake stroke, where both those valves are open, that's known as valve overlap. So that's like basic FA test questions is asked 3 or 4 different ways. They'll ask you, of course, what are the events? Intake, compression, ignition, power, and exhaust, the events. And then they'll ask you, when does valve overlap occur? Valve overlap, as we said, occurs at the end of the exhaust stroke. And right about where this piston here's the crankshaft's rotated down here about probably 30, 40 degrees or so past top center. That's actually where the exhaust event ended and ending that valve overlap period. But the idea here is we've got the exhaust, the intake valve open already on the end of that exhaust stroke. So that way, once the piston hits top center here and the valve is fully open, it's ready to pull in as much of that fuel-air mixture as possible. Let me check my time here. Oh, we're doing good. Okay. So valve overlap occurring at the end of the exhaust and the beginning of the intake stroke, where both your intake and exhaust valves are open at the same time. Valve overlap is designed into the engine to try and give me the best volumetric efficiency that I can get. And so the idea is that once we began that intake stroke, the intake valve was full open, giving me the best chance to draw in as much of that fuel-air mixture in the cylinder. And so, volumetric efficiency. Let's go ahead and list down a second thing that valve overlap does for us. So the main reason, so when you got an FAA test question asking, what's the main reason of valve overlap? That's to give you the best volumetric efficiency for the engine. Then there's a second thing that they ask is, what's the promote? There's the word I'm looking for. What does valve overlap promote? And the answer to that is scavenging of exhaust. So it helps with cooling valves and helps to scavenge the exhaust gases out of the cylinder. So let's take a second to look at that. When I am over here on the exhaust stroke, or the exhaust event is occurring here, and as I mentioned, if I get my piston up here about 10, 15 degrees before top center, the exhaust valve is already open, but then the intake valve starts opening. And what that does is, as these exhaust gases are actually the cylinder, helps to actually draw in some of the cooler fuel air mixture and draws it across and helps kind of push the last of those exhaust gases out. So it helps the cylinder kind of breathe, if you will, kind of mixing in the fresh stuff and helping to push, having to push the exhaust gases out of there. So that's what we call scavenging of the exhaust gases. Whereas the second part was helping that fresh, cool fuel air mixture flow across here, help with cooling. So that's where we kind of sum up that statement where we say, main reason for valve overlap, which is valves are open at the end of the exhaust stroke and the beginning of the intake stroke, where both valves are open at the same time. Main reason is to promote, or excuse me, I don't want to use the word promote, main reason is for volumetric efficiency. But then the second thing that the valve overlap helps promote is scavenging of exhaust gases and cooling characteristics of the cylinder, mainly helping to cool that exhaust valve down a little bit. One thing I might mention at this point too, the valves having all that heat problem, these valves that we have, the exhaust valves, these are actually hollow on the inside, and they're filled with, I'm losing the term right now. Anyway, they've got a coolant, basically, a liquid on the inside of these things, which helps transfer the heat better. And as soon as I get back into that, get my brain working, we'll talk about that a little bit better there. Anyway, okay, so we've got our 4 strokes talked about. We just talked a little bit about the intake event. Oh, and the intake event, as I mentioned, was from all the, over here on the exhaust stroke. So the event actually began on the stroke prior to its actual called intake stroke. So the intake event over here began on the exhaust stroke as we're coming up. We got both those valves open at the same time. Then the event, of course, is occurring during the complete intake stroke. Once we hit bottom center, we don't want to just close that intake valve up there because the gas is being compressible and expandable. They then are still wanting to flow in the cylinder. So we don't want to discourage that fuel air mixture from flowing into the cylinder. So once we hit bottom center down here, intake valve still open, and then we go over here to our compression stroke. We start up, and it is right about here when we look at the data when these valves open and close, right about when the crankshaft is here, probably 45 degrees before top center is when the intake valve will have closed and of course ended the intake event. So your intake event is basically from when the intake valve opened on the exhaust stroke, was open the full duration of the intake stroke, and then of course finally closed over here on the compression stroke. So anyway, okay, as we get into some next parts of the video, we'll talk a little bit more about the additional events there. Okay, I'm going to close this down.